going to think today a little about what happens when we reflect certain functions in the x-axis or reflect them in the y-axis. Let's consider first reflecting in the y-axis. Let's take a function. Let's say we've got here y equals x squared minus 2x. Okay, that's our function. In fact, let's even write it in function form. It might look a bit easier to understand there. So function of x equals x squared minus 2x. Let's use a table of values to actually plot a few points here. Okay. When x equals, let's start at the other end, it's probably easier. When x equals 3, what does the function equal? Anyone? When x equals 3, the function equals 3. 9 minus 6 equals 3. When x equals 2, what does the function equal? 0. 1. Equals 1, it's minus 1. 0. Negative 1.
2. Negative 3.
Let's think about it. Negative 1 squared is 1. Take away 2 lots of negative 1, which means add 2. So that's 3. Okay. So, what have we got? We've got negative 1, 3, 0, 0, 1, negative 1. Yeah. Here. So we've got a... Right. So we've now got a parabola there. Let's actually label these points. So 3, 3. We've got 2, 0, negative 1, negative 1. 0, 0, and negative 1, 3. Okay. Now, if we were to reflect that function in the y-axis, and let's actually do it using the points. Okay? So let's start, and I want to draw this I'll draw this in red. This will help us to see it. I want to start by reflecting this point here. If I were to reflect this point in the y-axis, what do I mean by that? So I want to put it into their own words. What do I mean? It means I'm actually saying, well, I'm taking this point and I want to put it on the other side of the y-axis, the same distance from the y-axis. I'm going to move it horizontally, the same distance on the other side of the y-axis. It's like that whole kind of butterfly painting you did in primary school. Put some paint on one side and you squash it together and you pull it apart and you got the same paint on the other side of the fold, the same distance from the fold, just moved horizontally. Does that make sense? Okay, and so where does this one move to? I want to move it here. What distance is that? 1. So I'm going to move it this way. 1. So that point there is what?
1. So
it's not going to be 2. Because I've moved it 1 here, while the distance from the axis is 1, and so just
1, 3.
1, 3. That's right. This one here, how far is that from the y-axis?
3.
So when you reflect it, what happens to it? Stays there. Okay. That one stays there. This one here, negative 1, negative 1. Sorry, that's not negative 1, it's a positive 1. Negative 1, sorry, I got it wrong. 1, negative 1. Where does it go to?
Negative 1, negative 1.
It goes to negative 1, negative 1 over here. So again, it's got to move 1 that way, and so it moves 1 that way. This point here, 2, 0 moves to
negative 2, 0.
Negative 2, 0, and up here,
negative 3, 3.
Negative 3, 3. Okay. Not the greatest drawing, but that's kind of what it is. So I've reflected it, and you kind of see, again, that everything on this side, we've kind of just flipped it round And what was on the left-hand side of the y-axis is now on the right, and what was on the right is now on the left. But still the same distance from the y-axis. Make sense? If we were to draw a table of values for our reflection, okay, that's my new points. And let's actually start, we'll start in the order that we did the reflecting. So what's this new one here? It's now 1 and 3. And what's this one here is 0, 0. And this one here is 1, so -1, -1. And here is -2, 0. And here is -3, 3. What do you notice about those two tables of values?
The x swaps. Signs. X.
Yep.
The bottom stays the same.
Yes. Yep.
It's a negative. It's just the opposite of the...
Yeah, so the x value has the opposite sign. And the y value has stayed the same. So to create a reflection in the y-axis, what have we done?
Times x by -1.
Yeah. We've actually put in the negative value of x. Okay, so our reflection, if we're calling g of x our reflection function, our reflected function, we've created it by just replacing all of the x's with a negative x. Okay? And it actually means, therefore, we can actually work out what the new function is. So therefore, g of x equals, well, what was our original function? It was x squared minus 2x. Let's put in a negative x into those. So I've just taken the same function I had before and put in a negative x where it was x. And so what does that give me? X squared. And what does this become? Plus 2x. So that red function there actually is x squared plus 2x.